Have you ever looked up at the sky and wondered if the universe has a message for you? Well, next week the cosmos is doing just that. Imagine stepping outside to see a giant smile in the sky formed by planets and the moon perfectly aligned. It sounds unreal, right? But it's happening. Are you ready to witness this celestial smile? Do you know when and where to look? Let's dive into this rare cosmic event, and I'll tell you everything you need to know to make sure you don't miss this amazing sight. Smiley face phenomenon. Imagine stepping outside on the morning of April 25th, 2025, and witnessing a cosmic smile lighting up the sky. It may sound like something from a sci-fi movie, but it's going to happen in reality. Venus, Saturn, and a crescent moon will align in a rare triple conjunction, forming a smiley face in the heavens. But why is this such a big deal? Well, planetary alignments don't happen every day, and this one is a true spectacle, one that you won't want to miss. The planets and the moon will line up perfectly, creating an image that looks as if the sky is smiling at us. And who wouldn't want to see that? It's like the universe is offering us a moment of joy, a celestial wink from space. So, get ready to witness something extraordinary. This event isn't just about catching a glimpse of a rare alignment. It's a reminder that the cosmos is always in motion, constantly shifting and changing in ways we can only begin to understand. The universe has a way of showing us just how interconnected everything really is, and this rare moment is the perfect example. If you've ever marveled at the beauty of the stars, or wondered about the forces that drive our solar system, this is your chance to connect with the stars in a way that's absolutely magical. So set your alarms, mark your calendars, and get ready for a morning sky like you've never seen before. Understanding a triple conjunction. So, you might be wondering, what exactly is a triple conjunction and why does this one matter? A triple conjunction occurs when three celestial bodies, planets in this case, appear close together from our perspective here on Earth. It's not just about seeing the planets align, it's about watching them move in a dance that's both beautiful and rare. In this event, Venus, Saturn, and the crescent moon will form a perfect triangular alignment. Picture this: Venus as the right eye, Saturn as the left eye, and the crescent moon forming the smile. This alignment won't last long, so make sure you don't blink. Now, alignments like this aren't completely rare. You might see a planetary conjunction every once in a while, but what makes this event so special is the timing and the exact positioning. The planets and the moon will align in a way that looks like a smiling face. It's a cosmic coincidence that's rare enough to make you stop and stare. This isn't just any planetary alignment, it's the universe sending us a friendly reminder of how tiny, yet wonderfully connected, we are in this vast cosmic tapestry. For stargazers, this is an opportunity to witness something truly special, an alignment that brings a sense of awe and wonder, reminding us of the beauty of our place in the universe. Optimal viewing time and location. Alright, so when exactly can you catch this cosmic smile? The best time to witness this planetary wonder will be at the crack of dawn on April 25th, 2025. But here's the thing, it's not going to be visible all day, so you'll need to set your alarm and be prepared for an early start. To get the best view, you'll want to look towards the eastern horizon just before sunrise, around 5:30 a.m. local time. You may be wondering, why so early? Well, this alignment happens just before the sun rises, so the planets will be low on the horizon. You'll have a brief window of opportunity, only about an hour, before the sun gets too bright and makes it difficult to see anything. The planets will be low enough in the sky to be visible to the naked eye, but the window of time is tight. Make sure you've got an unobstructed view of the horizon, away from tall buildings or trees that might block your view of the sky. This is your moment to capture that smile in the heavens, so be sure to get everything ready the night before. Don't forget your camera if you want to snap a picture. And hey, don't worry if you've never really looked at the sky this early in the morning, it'll be worth every second. What you'll see in the sky. Now let's talk about exactly what you'll be seeing. When you gaze at the sky, you'll notice the planets Venus and Saturn positioned to form the eyes, and the crescent moon curving perfectly beneath them to create the smile. It's like the sky itself is giving you a cosmic wink. Imagine the cool glow of Venus, bright and bold, paired with the ringed beauty of Saturn, and then, just beneath them, the delicate crescent of the moon, almost like a smile that's been painted in the sky. The alignment is unique not just because it's a rare event, but because of the way these celestial bodies will interact in our field of view. You won't just see the planets in a line, they'll be placed in such a way that their positions come together to form a smiling face. It's a cosmic portrait, a symbol of harmony in the universe, showing us how even the farthest objects in space can come together for a brief moment of perfect alignment. Watching this will definitely make you feel like you're part of something much bigger than yourself. Whether you're an astronomy enthusiast or simply someone who loves a good celestial spectacle, this rare alignment will leave you in awe. And who knows, you might even feel a little more connected to the stars and the mysteries of the universe after witnessing this beautiful smile in the sky. Viewing tips and equipment. So, you're probably wondering, do you need special equipment to see this amazing alignment? Good news, you don't. This event is visible to the naked eye, which means you don't need any fancy telescopes or binoculars to witness the magic. Of course, if you do have binoculars or a small telescope lying around, you might want to use them for a more detailed view of Venus, Saturn, and the crescent moon. You'll get to see Saturn's iconic rings and Venus's bright glow in all their splendor. But even without the extra gear, you're still in for a fantastic show. The key here is location. As we mentioned, you'll want an unobstructed view of the eastern horizon. Avoid areas with heavy light pollution or anything that might block your line of sight. And if you have a camera, this is your chance to snap a photo. Just make sure you adjust your settings to account for the early morning light. This way, you'll capture the alignment in all its cosmic glory. Whether you're using a smartphone or a DSLR, make sure to share your photos with friends and family. This is a moment you'll want to remember, and what better way to keep the memory alive than by capturing it for posterity? Who knows, maybe this rare alignment will inspire you to explore more of the night sky in the future. Why this event matters. Now let's take a moment to talk about why this event really matters. You might be thinking, it's just a smile in the sky. Why should I care? Well, let me tell you, this isn't just about a cool visual. It's a reminder of the incredible beauty and mystery of the universe. Our solar system is always in motion, but we rarely get to witness moments where everything aligns so perfectly. It's like nature's way of saying, look, I'm here, and I'm stunning. Watching this event will leave you feeling connected to something bigger, something far beyond our everyday concerns. These celestial alignments spark wonder and curiosity, and that's exactly what we need more of in our lives. Think about it. Every time we look up at the stars, we're looking at something that's millions or even billions of years old. These planets and moons are part of a cosmic dance that's been going on for eons, and this brief moment of alignment is just one chapter in the grand story of the universe. It reminds us that, while we may seem small in the vastness of space, we're also part of something incredibly beautiful and intricate. So, don't miss it. Take this chance to pause, to marvel at the night sky, and to reflect on how much we still have to learn about the cosmos. And who knows? Maybe this celestial smile will ignite a new passion for astronomy or simply bring a little more wonder into your day. Thanks for tuning in, stargazers. Don't forget to mark your calendars for this rare celestial smile, and share your photos with us. What do you think? Does the universe have a sense of humor? Drop your thoughts in the comments below. If you enjoyed this cosmic journey, make sure to like, subscribe, and hit the bell icon for more space wonders. Until next time, keep looking up and exploring the mysteries of the universe with us here at Space Facts. Have you ever wondered where everything came from? Like not just Earth or the stars, but space, time, and reality itself? What if I told you the entire universe was once smaller than a grain of sand? In today's video, we're diving deep into the ultimate origin story, the Big Bang. How did it happen? What came before it? And are we still feeling its effects today? Grab your curiosity because this journey will blow your mind. Ready to travel back 13.8 billion years? Let's explore the beginning of everything together. What was the Big Bang? Hey, have you ever looked up at the night sky and wondered, how did all this even begin? I mean, everything. The stars, the galaxies, the very space between them. It's mind-blowing to think that the entire universe once fit into something smaller than a pinhead. That's not just poetic, it's science. Scientists call it a singularity. No stars, no planets, no time, no space. Just infinite density and temperature packed into one unimaginable point. And then boom, about 13.8 billion years ago, the universe began. But here's the twist. The Big Bang wasn't an explosion in space. It was the sudden expansion of space itself. Space stretched, time ticked for the first time, and matter began to form. From nothing came everything. There wasn't some big kaboom with fireworks flying into empty darkness, because there was no outside to begin with. The Big Bang created space, time, energy, and all the rules that govern our reality today. It's like reality booted itself up from zero. And here's the real kicker. You, me, the device you're watching this on, we're all made of the same ancient energy that burst forth from that original moment. So next time someone asks where you're from, you can say, the Big Bang. It's not just science fiction, it's your origin story. The first moments. Alright, let's zoom in on those first few mind-melting moments after the Big Bang. And by moments, I mean we're talking less than a trillionth of a second. Imagine the universe going from microscopic to cosmic in the blink of an eye. That's called cosmic inflation. It's not just fast, it's ridiculously fast. We're talking faster than light expansion. In this phase, space itself stretched so rapidly that tiny quantum fluctuations, tiny ripples in the energy fabric, were stretched into the seeds of galaxies. No joke, those little wiggles eventually became us. During this period, the fundamental forces of nature began to separate: gravity, electromagnetism, and the nuclear forces. Think of it like the universe untangling its own rulebook while it was still being written. And even though it was blazingly hot, energy condensed into particles, the first building blocks of matter. We're talking quarks and electrons, not yet atoms, but the very idea of matter. It's wild to think that everything we see today, galaxies, black holes, pizza, memes, started from this chaotic, intense moment. Inflation not only made the universe big enough to evolve, but also smooth enough to become the calm cosmos we observe now. And the best part? We can still see the echoes of that inflation today. The afterglow is still out there, frozen in time, whispering the universe's birth story across the sky. Big Bang nucleosynthesis. So now that the universe has gone from a quantum seed to an expanding, fiery mess, what's next? It cools down just enough to start cooking, and I mean literally cooking elements. Around 3 minutes after the Big Bang, yeah, just 3, the temperature drops to about 1 billion degrees. That's when something magical happens. Nucleosynthesis. Protons and neutrons start teaming up, fusing together to form the very first atomic nuclei. Not full atoms just yet, but the cores. The recipe was simple, but it changed everything. Take a bunch of protons, stir in some neutrons, apply insane heat, and you get the universe's first ingredients: hydrogen, helium, and a sprinkle of lithium. That's it. No gold, no oxygen, no iron. Just the basics. But these basic ingredients were like cosmic Lego bricks. They were the raw materials from which stars, galaxies, and life itself would one day form. Think about it. Every drop of water, every breath you take, every cell in your body is built on the foundation laid during those first few minutes of creation. And what's even cooler, the predicted ratios of these elements match exactly what we see in space today. That's how scientists know this theory is on the right track. The Big Bang wasn't just an origin story, it was the universe's first chemistry class. And you're the long-term result of its wild experiment. The universe's afterglow. Let's jump ahead to a universe that's about 380,000 years old. By cosmic standards, it's still just a baby, but something extraordinary is about to happen. Until now, the universe has been a swirling, chaotic plasma soup, so hot that light couldn't travel freely. Photons kept crashing into free electrons like bumper cars in a demolition derby. But suddenly, the universe cools just enough for electrons and nuclei to finally bond and form neutral atoms. And boom! Light breaks free for the first time. That ancient light is still traveling across the cosmos today, and we call it the Cosmic Microwave Background, or CMB. It's like the baby picture of the universe, faint, stretched-out radiation that tells us what the universe looked like when it was just a few 100,000 years old. And guess what? Scientists have captured it. It's not just theory, they've measured it with satellites like COBE, WMAP, and Planck. What they found was astonishing, a nearly perfect glow spread across the entire sky with tiny variations that hinted at future galaxies. So when you stare up at the night sky, just know you're bathing in ancient light. It's the literal afterglow of creation. The universe left us a message in its own light, and it's been whispering its story for almost 14 billion years. Kinda romantic, right? Evidence supporting the Big Bang theory. Okay, so all this Big Bang stuff sounds cool and cosmic, but let's be real. How do we actually know any of this happened? I mean, it's not like we were there with a camera 13.8 billion years ago, right? Well, this is where science flexes hard. The Big Bang Theory isn't just a wild guess, it's backed by solid, observable evidence. First, up galactic redshift. When we look at distant galaxies, their light is stretched, shifted toward the red end of the spectrum. Why? Because space itself is expanding, pushing galaxies apart. It's like raisins moving apart in rising dough. Second, remember the cosmic microwave background we just talked about, that faint glow? It's exactly what you'd expect if the universe started as a hot, dense fireball. Third, we have the elemental recipe. The universe's mix of hydrogen, helium, and lithium perfectly matches the predictions made by Big Bang nucleosynthesis. It's not just a lucky guess, it's precise. Scientists didn't just make this stuff up after seeing the results, they predicted it first, and the results matched. That's what makes it so compelling. The universe isn't keeping secrets, it's actually leaving breadcrumbs all over the place. And we've been smart and curious enough to follow them. That's why, today, the Big Bang Theory is the most widely accepted explanation for the universe's origin. It's not just a theory, it's evidence-based storytelling written in starlight. Ongoing mysteries and the role of dark components. Now, before we all pat ourselves on the back, let's admit something. We don't have all the answers. Not even close. In fact, 95% of the universe is still a total mystery to us. Yeah, you heard that right. Everything we can see, stars, planets, people, pizza, that's just 5%. The rest, it's made up of dark matter and dark energy. Sounds like something out of Star Wars, but it's real. Dark matter doesn't emit light, doesn't absorb it, and we can't see it, but we can see its effects. It's like a ghost holding galaxies together, adding gravity where there shouldn't be enough. And then there's dark energy, the invisible force pushing the universe to expand faster and faster. Imagine driving a car that accelerates on its own and you can't find the gas pedal. That's our universe right now. These two dark components dominate the cosmos, but we barely understand them. It's humbling, isn't it? Even after decades of research, we're still staring into the dark, asking questions. And maybe that's the best part. The Big Bang doesn't just give us answers, it gives us better questions. It reminds us that curiosity is infinite, just like the universe. Expansion continues. So now we know how the universe began, but here's the final question. How will it end? Will the universe go out with a bang, a whimper, or something we can't even imagine yet? Let's talk about the possibilities. First, if dark energy keeps pushing everything apart, galaxies will drift so far away from each other that the night sky will go dark, literally. Stars will die out, matter will decay, and we'll be left with a cold, empty void. Scientists call this the Big Freeze or heat death. Not exactly cheerful, right? Another theory? The Big Rip, where expansion gets so intense that it tears galaxies, stars, planets, and even atoms apart, like the universe is being pulled apart at the seams. Then there's the Big Crunch, a sort of cosmic rewind. If gravity somehow wins over dark energy, the universe could collapse back into a singularity. Boom, back to square one. And hey, there's even the bounce theory, where the universe ends and begins in an endless cycle of bangs and crunches. We don't have the final answer yet, but we're watching the clues. Telescopes, satellites, simulations, they're all trying to read the universe's endgame. One thing's for sure, we're living in a cosmic story still being written, and isn't it wild that we're here right now, on this tiny blue dot, wondering how it all began, and how it might end? And just like that, we've traveled from the tiniest singularity to the vast cosmos we call home. The Big Bang isn't just science, it's our origin story, written in stars and stardust. If this blew your mind even a little, imagine what else the universe is hiding. Don't forget to hit that like button, subscribe, and ring the bell so you never miss a cosmic journey. Got questions? Drop them in the comments. I love hearing your thoughts. This is Space Facts, and the universe is just getting started. Until next time, keep looking up. Have you ever wondered how the universe will end? What will happen to Earth, to the stars, and to everything we know? Imagine watching time unfold at a breathtaking speed, from the rise of civilizations to the ultimate fate of everything. What does the future hold for us and for the universe itself? Time-lapse of the future. A journey to the end of time takes us on an extraordinary ride, offering a glimpse into a future that is both awe-inspiring and a little unsettling. Are you ready to explore the mysteries of time? Let's dive in and find out together. Journey to the end of time. Have you ever wondered what the future holds? Not just the near future, but the distant, unfathomable future of the entire universe. Imagine if we could compress billions of years into just a few minutes. That's exactly what time-lapse of the future, a journey to the end of time, does. This isn't just a time-lapse of Earth or our solar system, it's a cosmic odyssey that takes us from the present day all the way to the ultimate fate of the universe. Created by John Boswell, this 29-minute film offers a breathtaking exploration of what's to come as time unfolds, both for our planet and for the universe at large. As the future speeds by in a few short minutes, we're given a front-row seat to the wonders and the mysteries that await us. From human achievements to the most extreme cosmic events, this film pushes the boundaries of what we think we know about time and existence. You'll experience the rise and fall of civilizations, the birth and death of stars, and the transformation of entire planets, all happening at once in a stunning visual representation. The film opens in the year 2019, introducing us to the Anthropocene, a new geological age defined by human impact on the planet. But this is just the beginning. What happens next is both awe-inspiring and sobering. The film takes us on an incredible journey, showing us how the world changes faster than we can ever imagine. And ultimately, how everything, even the universe itself, will meet its end. It's a thought-provoking ride that leaves you contemplating your place in the vast, ever-moving river of time. And the best part? It's not just a journey of the mind, it's a visual experience you won't forget. The Anthropocene and human milestones. The future isn't just about what happens to the universe, it's also about what we, as humanity, will achieve along the way. Time-lapse of the future begins by placing us at the dawn of the Anthropocene era. The world we know today is shaped by human progress, and while it's easy to focus on the challenges we face, this film reminds us of our potential. The Anthropocene marks the point in time when human activity began having a profound and lasting effect on the Earth, everything from the construction of cities to the rise of new technologies. As we move through the future, we witness the incredible milestones humanity will achieve. Imagine this. Humanity has finally set foot on Mars, opening the door for interplanetary travel and establishing our presence on another world. This isn't science fiction anymore, it's a possibility within reach, and that's just the beginning. The film zooms in on our future space explorations, including the possibility of human settlements beyond Earth. What will it be like to live on Mars? How will we adapt to the harsh realities of space, and what role will technology play in our survival? But the journey doesn't stop there. It's not just about getting to Mars. The future is filled with even more ambitious plans, from harnessing the power of renewable energy on a global scale, to potentially even altering Earth's environment to make it more hospitable for future generations. With every milestone, humanity takes a step closer to becoming a true spacefaring species. As the years pass in this fast-forwarded timeline, we see Earth transform in ways we can only dream of today. It's a future that inspires us to think bigger and bolder about the path ahead. Cosmic events and Earth's transformation. As the future unfolds, Earth undergoes monumental changes, but it's not just human progress that takes center stage. It's the unpredictable and sometimes violent forces of nature that shape the planet. Imagine watching as Earth evolves over millions of years, transforming before our very eyes. In this section of the time-lapse, the film highlights the dramatic events that will change our world forever, many of which seem almost too extraordinary to believe. First, we witness the return of the famous comet Hale-Bopp in 3357. Its presence in our sky would be nothing short of awe-inspiring, a cosmic reminder of the vastness of space. But that's just the beginning. Over time, Earth's environment begins to shift in radical ways. Sea levels rise, submerging vast portions of the planet's coastlines, and the Earth's surface starts to look vastly different from anything we recognize today. Imagine cities swallowed by the rising tides, leaving behind only the memory of a once-thriving civilization. But there's more. In the year 5360, an asteroid impacts Earth, triggering a global catastrophe. It's a stark reminder that no matter how advanced we become, the forces of nature remain unpredictable and powerful. As the film continues to move forward, the Sahara Desert, once an arid wasteland, transforms into a lush, tropical landscape, showing how climate and geography can change in the blink of an eye. As the years press on, humanity might not be the only intelligent species we encounter. In 4226, the Voyager 1 spacecraft passes by the star Gliese 445, which is expected to be one of the nearest stars to Earth. Could there be alien life forms beyond our understanding? This section of the time-lapse reminds us of the fleeting, fragile nature of our world. and how everything, every creature, every city could be erased by forces much greater than ourselves. The death of the sun and the end of life. The inevitable truth is that no matter how much we achieve as a species, no matter how far we venture into space, the end of life as we know it is written in the stars. Fast forward to over 2.9 billion years in the future, and the Earth we know is no longer recognizable. The sun, which has sustained life for eons, begins its final transformation. Its increasing luminosity marks the death of all plant life, a harbinger of the slow, relentless extinction of everything dependent on the sun's energy. The oceans, once teeming with life, slowly evaporate and Earth's atmosphere becomes increasingly hostile. The temperature rises to unbearable levels, making it impossible for life to survive. As the sun continues to expand into a red giant, it engulfs the Earth, turning our once vibrant planet into a lifeless, scorched rock. It's a poignant moment in the time-lapse, one that forces us to reflect on our place in the universe. Yet as heartbreaking as this destruction seems, it is merely the beginning of a much grander cosmic evolution. As Earth is consumed by the sun's final stages, our star becomes a white dwarf, its once blazing heat reduced to a faint cold glow. It's the ultimate reminder of the impermanence of everything, even the stars that have guided us through the darkest nights. This segment in the time-lapse doesn't just show us the death of a planet, it challenges us to think about our own legacy in the grand scheme of the universe. What will remain when humanity is gone? What mark will we leave, if any, on the universe as time marches relentlessly forward? The degenerate era and black hole dominance. As the universe continues its journey through time, it enters a period of profound transformation. Welcome to the degenerate era, a future where the stars, once burning bright with energy, have exhausted their fuel and faded into the cold darkness of space. It's a universe populated by the remnants of stars, white dwarfs, neutron stars, and the towering, mysterious black holes that dominate the cosmos. These dead remnants continue to drift through the void, their existence marked by the slow ticking of time, a stark contrast to the vibrant explosions and glowing nebulae we see today. In this era, gravity becomes the universe's most powerful force. With most of the stars having burned out, the universe grows darker, quieter, and colder. The once glorious spiral galaxies we recognize today are no longer filled with the radiant light of stars. Instead, they're populated by these invisible giants, black holes, absorbing all matter that comes near, growing ever larger with each passing century. Entire star systems are swallowed up, never to be seen again, as the universe slowly empties. This era is a chilling reminder of the universe's eventual entropy. The once luminous galaxies and nebulae that filled the night sky are replaced by the crushing silence of space, where the only sign of life is the slow, inevitable death of the stars. It's an era where time seems to stand still, and life, as we know it, seems like a fleeting memory in the vast, unchanging expanse of space. The degenerate era asks us to confront a harsh reality. In the grand scheme of things, our existence is but a brief moment, a tiny spark in the dark void of eternity. The black hole era and proton decay. As the degenerate era fades, we enter the black hole era, a time where the universe is defined by the influence of its most enigmatic and powerful objects, black holes. These cosmic giants, which are already a dominant force in the universe, begin to completely shape the destiny of all matter. Over time, the black holes grow even larger, their immense gravity warping space-time itself, pulling everything in their path into their all-consuming depths. But this isn't the end. Even these mighty black holes eventually face their own end. In a mind-boggling twist, the universe's matter begins to disintegrate. Protons, the building blocks of atoms, start to decay, turning the universe into an even more barren place. It's almost as though everything that once defined the universe, the stars, the galaxies, the very atoms, slowly unravels at the seams. The film imagines a universe where matter no longer behaves as it once did, where even the most basic building blocks are no longer stable. This process of proton decay leads to the disintegration of everything, as atoms break apart and the universe becomes a giant sea of radiation. In the black hole era, the universe is no longer the lively, dynamic place we know. Instead, it's a cold, lonely expanse, dominated by the power of black holes and the gradual decay of all matter. As stars and galaxies fade away and even the basic structure of atoms dissolves, time itself becomes meaningless. What remains? just a vast emptiness where the only thing left is the lingering presence of black holes, reminders of the cosmic events that once filled the universe with light and energy. The end of the universe and the arrow of time. And so we reach the end of the universe, a final chapter that is as inevitable as it is awe-inspiring. The universe, once filled with stars, galaxies, and the potential for life, slowly fades into an unimaginable void. The last black hole, having consumed everything it could, begins to evaporate, a process known as Hawking radiation. This marks the final moments of the universe's existence as we understand it. The fabric of reality itself begins to unravel, and all that's left is the ultimate fate of everything, a dark, cold, lifeless void. But even in this end, there is a sense of profound beauty and mystery. As the universe reaches absolute zero, time itself ceases to have meaning. The film takes us on a journey through this cold, silent expanse, asking us to reflect on what it means for time to end. It's a haunting thought, yet an essential one. The arrow of time, which once moved in a clear direction from past to present to future, reaches its final destination. The film concludes with a powerful meditation on time itself. Brian Cox's narration reflects on the fleeting nature of existence, urging us to appreciate the present moment. The universe may be dying, but our consciousness, our awareness of time, is alive. In these final moments, we are reminded that even in the face of absolute destruction, there is value in our brief shining moment of existence. This ending is as much a philosophical statement as it is a cosmic one. It forces us to confront the ultimate question: what will we leave behind when time itself expires? In a universe where everything eventually fades away, the question of meaning becomes all the more pressing. The universe may end, but our understanding of it, and our connection to it, remains as the final spark of life in the vast, endless dark. And there you have it, an incredible journey through the future of the universe. From the rise of humanity to the unimaginable end of time, we've explored the mysteries of space like never before. What did you think? How do you imagine the future unfolding? Drop your thoughts in the comments below. We'd love to hear from you. If you enjoyed this mind-blowing ride through time, don't forget to like, share, and subscribe to Space Facts for more incredible content about the wonders of the cosmos. Until next time, keep looking up, there's so much more to discover. What if I told you the universe is being pushed apart by something we can't see, touch, or fully understand? A mysterious force that makes up nearly 70% of everything, yet remains invisible. Yeah, I'm talking about dark energy, the biggest cosmic enigma out there. But what is it really? Why is it making the universe expand faster and faster, and what does that mean for the future of everything we know? Grab your curiosity, because today we're diving deep into a mystery that's literally shaping the fate of the universe. Are you ready to explore the unknown? What is dark energy? Have you ever felt like the more we learn about the universe, the less we actually know? Well, dark energy is the perfect example of that mystery. Scientists say it makes up nearly 68% of everything in the universe, yet we can't see it, touch it, or directly detect it. So, what is it, honestly? We don't fully know. But here's what we do know. Something out there is pushing galaxies apart, faster and faster. And that something is what we call dark energy. Imagine blowing up a balloon. You expect it to slowly stop expanding as the air fills it, right? But dark energy? It's like the balloon is speeding up the more you inflate it, defying expectations. That's exactly what the universe is doing. Instead of slowing down from the pull of gravity, it's accelerating outward. It's wild. Some think dark energy might be a property of space itself, like empty space still has energy. Others believe it could be a new kind of field or particle that we haven't discovered yet. Whatever it is, it acts like an anti-gravity force, stretching space over time. And the craziest part? It's everywhere. Right now, as you're watching this, space is expanding even in the vast emptiness between galaxies, and dark energy is driving that. So yeah, it's invisible, mysterious, and it's changing how we understand the very fabric of the cosmos. The more we search for answers, the more it pulls us into its mystery, just like it's pulling the universe farther and farther apart. Discovery of dark energy. Okay, let's rewind to the late 1990s, a time of chunky computers and questionable fashion choices. Astronomers were studying supernovae, those dramatic explosions that mark the death of massive stars. The plan was simple: Measure how fast the universe was expanding and see how gravity was slowing it down. That's what they expected. But what they found? It flipped everything on its head. Instead of slowing down, the universe was actually speeding up. Imagine expecting to see a car decelerate after going up a hill, and instead it starts zooming faster, all on its own. That's how bizarre it was. Scientists were stunned. Something unknown was pushing the universe apart, and that something was quickly named dark energy. This wasn't just a tiny discovery, it was a cosmic bombshell. Two independent teams, both using different data, came to the same jaw-dropping conclusion. The expansion wasn't just continuing, it was accelerating. And suddenly, all those neat theories about a balanced universe, tossed out the window. In 2011, the Nobel Prize in Physics was awarded to the leaders of those teams. Why? Because they basically rewrote the rules of cosmology. This discovery didn't just suggest a new force, it demanded it. And that force is dark energy, mysterious, unstoppable, and quietly shaping the entire universe while we're just here, trying to keep up. The role of the cosmological constant. You know what's wild? Einstein may have accidentally predicted dark energy more than 100 years ago. And then called it his biggest mistake. Yeah, really. He added a term to his equations called the cosmological constant, thinking it would keep the universe static because back then, everyone believed the universe wasn't expanding at all. But when Edwin Hubble showed that the universe was expanding, Einstein scrapped the idea thinking he'd been totally off. Turns out, he might have been onto something big. Fast forward to today, and scientists have brought the cosmological constant back from the grave. Why? Because it might just explain dark energy. Picture space itself having a kind of built-in energy, a quiet, invisible pressure that doesn't fade with time. That's what the cosmological constant represents. A steady, constant push that fills space and drives the universe to expand faster and faster. It's like a cosmic thermostat set on expand, always pushing outward no matter what. And it's not affected by matter, temperature, or time, just there, humming along in the background of reality. Some scientists think dark energy is this constant force Einstein once described. Others think it could be something dynamic, something that changes over time. But here's the big takeaway. Even when Einstein thought he was wrong, he may have glimpsed one of the universe's most powerful forces. The cosmological constant is now a leading contender in the race to explain the invisible hand stretching our universe apart. Crazy how science can loop back around like that, right? Dark energy versus dark matter. Let's clear something up because these two get mixed up a lot. Dark energy and dark matter are not the same thing, not even close. They may both sound like mysterious sci-fi terms, but they do completely opposite things. Imagine dark matter as the universe's glue, while dark energy is its great escape artist. Dark matter pulls things together. It's the invisible mass that helps galaxies form and stay intact. Without it, galaxies would fly apart because there wouldn't be enough gravity to hold the stars together. We can't see dark matter either, but we know it's there because of how it bends light and affects galaxies' movements. Think of it as the unseen hand keeping the cosmic dance from falling apart. Now, dark energy? That's the rebel. It doesn't pull, it pushes. It drives galaxies away from each other, accelerating the universe's expansion like a cosmic engine with no brakes. While dark matter works on local scales like within galaxies, dark energy works on the grandest scale imaginable, affecting the entire universe. Here's an analogy. If the universe were a cake baking in the oven, dark matter would be the flour holding everything together. Dark energy, that's the yeast, making the cake rise faster than expected. So yeah, dark matter is pulling the universe in, dark energy is blowing it apart. Two invisible forces, two cosmic mysteries, both completely changing how we understand space, time, and everything in between. The impact on the universe's fate. Alright, let's get deep for a second. If dark energy is real, and all signs say it is, it's not just tweaking the speed of our universe's expansion, it could be deciding the fate of everything that exists. I'm talking about galaxies, stars, planets, even atoms. Yeah, it's that big of a deal. So what happens if this dark energy keeps doing its thing forever? We might be looking at the big freeze. Sounds dramatic, right? But it's more like a slow fade. Galaxies will drift farther apart, stars will burn out, and over trillions of years the universe will become cold, dark, and silent. A frozen cosmos. Forever. But hold on, it gets even more bizarre. What if dark energy doesn't stay constant? Some theories say it might get stronger over time. If that happens, we're heading straight toward a terrifying idea called the Big Rip. Picture this. galaxies tearing apart, then stars, then planets, then, eventually, you. Even atoms wouldn't survive. Everything gets shredded by expansion itself. It's like the universe hits the gas pedal and never lets go. Of course, there's also the opposite idea. What if dark energy weakens or even reverses? Then gravity might take over again and cause a big crunch, pulling everything back together into a dense point. The whole universe would collapse on itself, maybe even leading to a new Big Bang. No pressure, right? Just a mysterious, invisible force quietly deciding the ultimate ending of reality as we know it. The truth is, we're still in the dark. But one thing's clear, dark energy isn't just a background character, it's the main act in the story of the universe's destiny. Ongoing research and theories. Let's be real, dark energy sounds like something out of a sci-fi movie. But scientists around the world are working non-stop to figure out what it actually is. And they're getting creative about it. Like, seriously, next-level creative. One of the biggest efforts is the Dark Energy Spectroscopic Instrument, or DESI. It's mapping the positions of millions of galaxies to see how the universe has expanded over time. Think of it like taking a cosmic time-lapse. The more we learn about how galaxies moved in the past, the more we can understand what dark energy has been doing. But DESI isn't alone. The Euclid mission by the European Space Agency and NASA's Nancy Grace Roman telescope are also joining the hunt. They're aiming their eyes deep into space to catch clues about this invisible force. Scientists are hoping to figure out whether dark energy is constant, like Einstein's cosmological constant, or if it changes over time like a rolling wave. And then there are the mind-bending theories. Some physicists think dark energy might be connected to quantum fields. Others believe it could point to a hidden dimension or even support string theory. Yeah, the one that talks about tiny vibrating strings making up the universe. Here's the bottom line, dark energy is the biggest unsolved mystery in modern cosmology. We don't know what it is, we don't know how it works, but we know it's real. And it's rewriting everything we thought we knew about the universe. The more we search, the stranger it gets. And honestly, that's what makes it so thrilling. And that's the strange, fascinating world of dark energy. An invisible force that might just decide how the universe ends. Crazy, right? The more we learn, the more questions we uncover. If you found this mind-blowing or even slightly unsettling, you're not alone. Space is full of mysteries, and we're just getting started. So, if you love exploring the unknown, don't forget to subscribe to Space Facts for more deep dives into the cosmos. Until next time, keep looking up, because the universe has way more secrets waiting to be discovered.